Getting better at something takes practice. So let's get better at Postgres by doing some drills. As a warm-up, create a database that has a many-to-many relationship between customers and subscriptions. This means you're going to need a joining table to store an instance of a particular customer subscribing to a particular subscription tier. As an extension, see if you can make it so that the customer can only have one subscription. Pause the video here and see if you can implement it on your own. Okay, let's step through the solution. Now, I could teach you how to write this manually, but instead, I'm going to teach you how to make the robots write it. So here we have the Supabase assistant, which allows us to ask a question about our SQL query, or ask it to write an SQL query for us. So we want to create a many-to-many relationship between customers and subscriptions. Make sure each customer can only have one subscription. This also tests me because I don't know exactly what's going to come out the other side. So this is looking a little bit busy in this view. So let's click this button to move it across to the SQL editor. And we can also scroll up and close the assistant. So we have a customers table with an ID that's a big int. So we can store a ludicrous number of customers. It's our primary key and it's automatically generated for us as the identity for this table. We then have a name column, which I'm just going to fix up the case to be all lowercase. It probably doesn't matter like all of these other keywords, but I feel like I want that to be consistent. So we have an ID, we have a name, and we have an email column. This one's unique. So we're saying that we only want to have one customer that has a particular email address. That makes sense. And each of these columns are not null or mandatory. We then have another table for subscriptions with the same kind of ID, the same kind of name, which I'm just going to correct here, and then a price, which looks like it can store up to 2 decimal points. So I guess this is in dollars. I'm actually going to change this to be an int so we can store our subscription price in cents and avoid any weird rounding errors. But you might notice that subscriptions and customers are not actually related in any way yet. They just store data that's related to a customer, data that's related to a subscription. So if we want to relate these two together, we need a joining table, which is what we have here. So this table is called customer subscriptions. It's got a customer ID, which is just a reference to the customer's ID. And then it has a subscription ID, which is a reference to the subscription's ID. It looks like it's messed up which one of these we want to be unique. So we only want one customer to be able to have a subscription. So we probably want to move this one up onto this column. Otherwise, we wouldn't be able to have 2 customers that have the same subscription, which doesn't really make sense. We are also declaring that the primary key is the customer ID. We could actually just leave this, or we can make this a compound primary key of both the customer ID and the subscription ID. This is probably redundant in this case because the customer ID is unique and can therefore uniquely identify every row in this table, but it's best practice to make the primary key of a joining table a compound primary key between the 2 tables that it's joining. This also means if we were to remove that uniqueness constraint down the line, we would still be able to uniquely identify every row in this table based on the combination of a customer ID and a subscription ID. So this looks good. We can run this statement to create both our customers table, our subscriptions table, and then the joining table of customer subscriptions that creates that many-to-many relationship. And now we just need to insert some data. So again, we can use Supabase AI and say, create some test data for the schema you recommended. And let's move this one across to the SQL editor. And we can either insert or we can actually replace the code in the SQL editor. So we can accept this change and then close the AI assistant. And we can see this is inserting into customers the name and email of 2 very creatively named customers. And then for subscriptions, we have a name and price. So we have a basic plan at $10 a month. If we want to store this in cents, we could add 2 more zeros, or we could just decide that our system is only ever going to store whole dollars. So we're going to have a $10 plan and then a premium plan for $20. That looks good. So then we want to insert into our customer subscriptions table a customer ID and a subscription ID. So John is subscribing to the basic plan and Jane is subscribing to the premium plan. So we can run these ones to insert our example data, and we have successfully completed our warm-up. All right, hope you're feeling as loose and good as me. time for exercise 1. What we want to do is select each of our customers and the name of their subscription tier. This means we need to reach through the joining table to grab their subscription. So this is some example output of what we want to see. We only want one row for each of our users, and then we want the name of their particular subscription. Pause the video here and see if you can do this on your own. Otherwise, time to step through the solution. So let's start by selecting all of the columns from the customers table. So if we run this one, we can see we're getting ID, name, and email. So each of the columns from the customers table. We then want to join in an additional column for the name of their subscription. So there are a couple of different ways we can do this. We can either use a join or we can use a subquery to go and grab that extra data. I'm going to do a subquery first, and then we're going to refactor this to use a join. So we want to grab all of the columns from the customers table, and then we want a subquery to say we want to select the subscription underscore ID from our joining table. So that was customer underscore subscriptions, and we want the row where the customer underscore ID is equal to the customers table's ID column that we're currently selecting all of the columns for. And if we give this one a run, we can see each of our customer columns and then the ID for the particular subscription tier that each of our customers are paying for. We could also insert another customer that doesn't actually have a subscription, so we can see that empty state. So we'll call this one Mary Poppins, and the email is obviously mary.poppins@example.com. We can highlight just this one statement to run it in isolation, and now we have a customer with no subscription. So if we rerun this select statement, we'll see null as Mary's subscription ID. But we don't want this to be the ID, we want this to be the subscription's name. So how do we get that? Well, this joining table doesn't really help us because it only has a subscription ID and a customer ID. We don't have the subscription name. So to get that, we're going to do another subquery and select the name column from the subscriptions table, but we only want the subscription where the subscriptions.id matches the customer underscore subscriptions dot subscription underscore ID. So this is the subscription ID from the subquery that is selecting from the customer subscriptions table. So that's what we're getting back here. So we want to take that subscription ID and then look up the name column from the subscriptions table for that particular ID. So if we give this one a run, we only see the columns from the customers table. So obviously we've confused Postgres. So let's create an alias here to say we want this subquery to be labeled as the column subscription underscore name. Now, if we give this one a run, we can see a row for each of our customers and the name of the subscription they're paying for, or null if the user is not currently subscribed. Awesome. We completed our first drill. Doesn't that feel good? Don't you feel a little bit better at Postgres? Next up, we want to refactor this to use joins instead of subqueries. So this might be what you're more familiar with, or it might be what you're less familiar with, but it's really beneficial to be able to move between nested subqueries and joins. So try it, pausing the video here and see if you can do it on your own, or we can just go through the solution. Okay, so let's get rid of everything here, all of these nested subqueries, and say we want to select all of the columns from the customers table, and then we'll work out what we're going to do here to get the subscription name. So let's start by joining on that customer underscore subscriptions table, and then we need to tell it what we want to join on, so which columns have that relationship. So in this case, that is the customer underscore subscriptions dot customer underscore ID matching our current customer's ID. So we can check this part is working by saying we want to select the customer underscore subscriptions dot subscription underscore ID just to confirm we are joining this table correctly. And if we run this one, we see a couple of problems here. Firstly, Mary has disappeared. Let's deal with that one first. The reason Mary has disappeared is because by default, when we say join in Postgres, this does an inner join, which removes all of the null values. So if we have a customer who doesn't have a subscription, they're gone. So what we really want to use here is a left join, which will give us all of the customers, regardless of whether they don't currently have a subscription, and then join in all of the columns for the customer underscore subscriptions table if that particular user has a subscription. So let's run this and see where we're at. So we've got Mary back, which is good, but we have a customer ID, a subscription ID, and another subscription ID, and all of these are null for Mary. And this is because we're saying just select all of the columns, and Postgres is saying, sure, well, all of the columns are all of the columns from the customers table, and now it's also all of the columns from the customer subscriptions table. So I'll just give you all of them. But we don't actually want that, really. We just want all of the columns from the customers table, and then we want this additional one for our subscription name, or currently our subscription ID, but it will be our subscription name. So let's run this, make sure we fix the problem, and that looks good. We're back to a row for each of our customers, and then their subscription ID, or null if they're not currently subscribed. So now we just need to get the subscription name instead of the subscription ID. So let's also left join in our subscriptions table on the column subscriptions.id, matching the customer underscore subscriptions dot subscriptions underscore ID. And now that we've got all of the columns from that subscriptions table joined into our query, we should be able to say we want to select the subscriptions table's name column as our subscription name. So now if we run this one, we'll see I accidentally made a typo for subscriptions underscore ID rather than subscription underscore ID. And now we have a row for each of our customers with their name and email, and then the name of each of the subscriptions if they're subscribed, or null if they are not. And congratulations, you have just completed probably the hardest drill of this whole set. All right, last one. I want a list of each of our customers and then whether or not they are subscribed. So the result set should look something like this, and I really want you to pause the video and see if you can do it on your own. Come on, you did that last one. You can definitely do this one. Okay, time for the solution. Okay, so let's start by just selecting all of the columns from our customers table. And if we run that one, we can see each of our customers. Now we just want to add on a column for whether they are subscribed or not. So for this one, I'm going to use a subquery. I probably prefer that for this example because, again, we're trying to work something out. We just want to know whether this customer is subscribed or not. We don't care about joining in all of those columns, but up to you. You can use a join if you would like. So we can alias this subquery to be is underscore subscribed. And then our subquery is basically just going to check, is this customer in our customer underscore subscriptions table? So we can check that by saying, well, select star for now from the customer underscore subscriptions table, where the customer underscore ID is equal to our customer's ID that we're currently selecting all of the columns for. And if we run this one, we'll get another error because we can't spell. This should be the customer's ID, but now we get the correct error that a subquery must return only one column. So here we're selecting all of the columns, so we could select just the ID, for example, and then run this, and we get back each of our customers, and then a number if they're subscribed and null if they're not. So since we don't actually care about the value that comes back here, we only care whether this exists or not, we can replace this with select one. And so if we run this, we can see what that's doing. We either get back the value 1 if the customer has a subscription, or we get back null if they don't. So we can then wrap this in a call to the exists function, which checks whether a value exists in our subquery or whether the value is null. So now, if we give this one a run, we can see exactly what we're looking for, where we have a row for each of our customers and have appended on an is subscribed column with either the value true or false. So give yourself a pat on the back because you have officially completed another set of quite difficult drills. So this example used a many-to-many relationship, which is probably the most complex relationship in Postgres. If you want a little refresher on the other types of relationships, then check out this video right here. We implement a one-to-one, one-to-many, and many-to-many relationship and talk about when to use each one. If you're ready for the next topic, check out this playlist. But until next time, keep building cool stuff.